In this video, we are going to talk about identifying patterns in nature using natural phenomena and objects, as well as appreciating mathematics in one's life. All of us use mathematics every day. From the time we wake up, we take a look at the clock and count how many hours we spend sleeping. Right, numbers. Certainly, we use numbers every day whenever we do shopping, be it at the mall or online. We spend money and of course it involves mathematics. Whatever fields we're in, surely there's mathematics. In finance, mathematics is used to observe the stock market. Economists who study the law of demand use mathematics. So, how can you define math? Some says it is a study of numbers and arithmetic operations. Some says math is a tool or a collection of skills that help us answer a question of how many or how much. And some individuals define mathematics as a science of logical reasoning, drawing conclusions from some premises or a strategic reasoning. Yes, those meanings are correct. But to be able to better understand mathematics, it is simply defined as universal, meaning even a single thing in your surroundings, you can find a math on it. Wherever you go or whatever you see, there is a math on it. In short, math is everywhere. Now that I already enlightened everyone about mathematics, let us proceed to our main topic, which is identifying patterns in nature using natural phenomena and objects. What is pattern? Pattern can be defined as regular, meaning it is consistent. Of course, repeated and recurring forms of designs. Natural phenomena are those that occur or manifest without human input. Examples of natural phenomena includes earthquake, waves, thunder, and many more.
Nature is symmetry. In general usage, symmetry most often referred to mirror or reflective symmetry, which indicates that you can draw an imaginary line across an object and the resulting parts are mirror images of each other. A common example of this is a butterfly. When you put an imaginary line across a butterfly, you can see that the left side of the image looks exactly the same as the right side of the image. The same goes with an isosceles triangle. When you put a vertical line right at the center of an isosceles triangle, you can see that the left side of the image looks exactly the same as the right side of the image. This also applies to our natural phenomena. For example, the perfect reflection of the sky in the clear ocean. As you can see in the photo shown, when you draw a horizontal line across the picture, you can clearly see that the ocean below clearly reflects the skies above, which makes the both sides looks exactly the same.
Fractals. Fractals are objects in which the same patterns occur again at different scales and sizes. It means when an object had the same appearance but they have different mass and or sizes. An example of a natural phenomena with a fractal patterns are stalactites and stalagmites. Stalactites is an icicle-shaped formation that hangs from the ceiling of a cave and produced by precipitation of minerals from water dripping through the cave ceiling, while stalagmites is an upward growing mound of minerals deposits that have precipitated from the water dripping onto the floor of a cave. So stalactites and stalagmites, they have the same appearance but when they are formed, they become smaller or in larger sizes. And that's what a fractal pattern is.
The third pattern of nature is tessellation. Tessellation are patterns that are formed by repeated cubes or tiles, or in short, it is called tiling. It is a way to cover a surface with a repeating pattern of flat shapes such that there are no overlaps or gaps. A good example to this is the honeycomb. In geometry, a honeycomb is a space-filling or close packing of polyhedral or higher dimensional cells so that there are no gaps. The interesting thing about honeycomb is its hexagonal shape in a repeating pattern that fills a space efficiently. In addition to that, only 3 regular polygons can form tessellations by themselves: triangle, square, and hexagon.
As we all know, mathematical pattern in natural phenomenon is a pattern that can sometimes be modeled mathematically, and they includes symmetry, fractal, tessellation, spiral, foam, and stripe. This has many types, and today I'm gonna tackle about the fourth pattern. The fourth pattern of natural phenomenon is foam. So, what is it all about? Foam pattern is an object formed by a trapping of gas in liquid or solid. In other words, foam is made up of bubbles packed loosely together, whisking water and air produces hundreds of bubbles, but they soon pop, leaving only water and air again. Eventually, the protein coating of the air packets links together, making a foam. To make you understand with this, spume is the best example of this. Spume is basically what we see at a shore. Why is the best example of foam pattern? Simply, spume form when gases are trapped in the water and then it forms bubbles in the ocean. Spume forms in this way, but on a much grander scale when the ocean is agitated by wind and waves. Everything that form into bubbles is basically all about foam pattern. That's all. I hope you all understand what I have tackled today. Thank you.
The fifth pattern is called spirals. A spiral is a curved pattern that focuses on a center point and a series of circular shapes that revolves around it. An example of a spiral are pine cones, pineapple, and a hurricane. A hurricane, also called a tropical cyclone, is a rapidly rotating storm system characterized by a low pressure center, a close-level atmospheric circulation, strong winds, and spiral arrangement of thunderstorms that produce heavy rains. While the reason for why the plants use a spiral form, like the leaf picture, is because they are constantly trying to grow but stay secure.
Lastly, the stripe pattern. The stripe pattern is a long, narrow band of strip, typically of the same width throughout its length, differing in color or texture from the surface on either side of it. The example of stripe patterns are rainbow and zebra rocks. Patterns in nature are visible regularities of form found in the natural world. These patterns occur in different contexts and can sometimes be modeled mathematically. Natural patterns include symmetries, fractals, tessellations, spirals, foams, stripes, and more. Overall, in mathematics, a pattern is a repeated arrangement of numbers, shapes, colors, and so on. If the set of numbers are related to each other in a specific rule, then the rule or manner is called a pattern. Then that would be all. Thank you.